Welcome to our presentation from Group 14, Arduino Pet Feeder. So first of all, let me talk about introduction. Why pet feeder? We have observed there is some problem for the pet owner that maybe they are not home, they don't have time to feed the pet, or they even forget. So we decided to make this machine that can feed the pet automatically. So we can set the time. We have observed that dog and cat should eat 2 times a day. And the owner can set, they can set 6 a.m. once and then 6 p.m. once when they're not home. So they don't need to worry about who's gonna give the pet food. So this is very useful for the pet owner, including me, that sometimes I'm not home. I need to call someone to, can you please feed my pet? But no one has time. So this machine is very useful. So we don't need to worry who's gonna feed our. So this is our first sketch. This is our just design. We want to make this box and then make the food come down from this hole. And before we wanted to use the keypad, but I think it's better to just set the time without just click. But in the beginning, the owner can set the time by themselves, so don't need to worry. So now let's talk about circuit and code description. These are the components we use. First, Arduino Uno, of course, and then breadboard, and then servo module. This is a very important component that make it open so that the food comes down. It uses servo motor, and then jumper wires, of course, to connect the breadboard and Arduino Uno. And then the screen, 16 multiple 2, 12C LCD. And then this thing is the clock. It's DS3231 RTC module, which is the clock that will show the time on the screen when you want to feed your dog or your cat. So when it's feeding time, the screen will change to feeding now. I will show you in the video. So this is our little process. First of all, we try to make the servo motor moving. You can see from this video, this is our first try. And then in the second video, we connect this servo motor to the plate so that it can just open and close. So we have to do it open 90 degrees and then come back and close. So what we try to do is we try to make it open for 4 seconds and then close only one time so that the food can come out for 4 seconds. And I think that's enough for the pet. And in the last video, you can see that we already done with the servo model and then connect it with the prototype so that you can see it's open and closed, so it works. So then we're gonna try to make a code works that it should open at only 4 seconds and then close. And then let's come to the screen. So this is our first try also, that we try to make the screen show the code, the words, or whatever. So we just try to make it have an output first, and then, as I said, we're gonna fix the code. So what we try to do is we try to make it pet feeder and then the time. So we try to set at 6 a.m. and 6 p.m. That's what we're gonna do. After that, we set the screen in the box so that it can show in the box while the food comes down, as you can see in the second video. And this is the third video that I show you all the wires, all the circuits behind this box, and that we stuck the screen inside and also servo inside, so you can see all from this video.
So for the code, first I include the necessary libraries. First is wire.h for I2C communication, and rtclib.h to work with DS3231 RTC, and the servo.h is for control the servo motor, and liquid crystal underscore I2C.h is for display tick on the LCD screen. This one is initialize devices and objects. I create objects for the RTC, servo motor, and the LCD display. The LCD uses the address 0x27, and the 16 and 2 here is just for my screen. You can change it if needed. And the set feeding times, I set it at 6 a.m. and 6 p.m. The first and the third is for time like hour, and the second and the fourth is for minutes, so I set it at 0. For the feeding status flags, these Boolean variables keep track of whether the feeder has already dispensed food at each scheduled time, so it won't dispense multiple times in the same minute. And the setup function, in the setup and bracket function, I start serial communication for debugging, initialize the RTC communication, start the RTC, attach the servo to pin D10, and I set the servo starting position at 00. Initialize the LCD display to pet feeder ready to show on the screen, and for the loop function to run and repeatedly. I get the current time from the RTC because I can check the real-time clock. Then store the current hour, minutes, and second in variables. Display time on LCD. Here I display the current time on the second round of the LCD. I also add the leading 0 if the number is less than 10 to keep the time nicely formatted. So for the feeding logic, 6 a.m. and 6 p.m. If it's exactly 6 a.m. and the feeder hasn't dispensed yet, I trigger the feeder and set the has fed 1 flag to true. When the time moves to a different minute, I reset the flag to false for the next day. And I use the same logic as 6 p.m. And for the delay 1 second, I add a 1 second delay so the time display updates every second. For the trigger feeder function, this function does the actual feeding. It clears the LCD and shows a message like feeding 6 a.m., rotates the servo to 90 degrees to dispense food, waits for 1 second, turns the servo back to 0 degree, waits half a second, then returns the LCD to display pet feeder ready. So for the circuit connections, let me explain how these components are connected. The RTC module and RTC display, they both use I2C communication, so they share the same two wires. It's SDA and SCL. For the SDA, it connects to pin A4 on the Arduino, and SCL connects to pin A5. Then the servo motor signal wire connects to pin D10, and the power pins VCC and ground are connected to 5V and ground on the Arduino, and all ground wires must be connected together to complete the circuit. As you can see in the slide that I put the picture, I sorry that I cannot find the DS3231 in the Tinkercad application. That's why I used this picture just for you for an example. For the benefits, first is convenience. It automatically dispenses food at scheduled times, saving your time and effort. Perfect for busy owners, travelers, or those with unpredictable schedules. 2. Portion control. It helps prevent overfeeding or underfeeding by dispensing exact amounts of food, which support your pet's weight and overall health. 3. Consistency. Feeds your pet on a regular schedule, reducing stress and creating a reliable routine, especially for pets that depend on consistency. 4. Reduces food waste. By dispensing only what needed, it minimizes food waste, spills, and spoilage. 5. Supports special diets. It's ideal for pet with dietary needs, allowing you to set specific portion sizes and times easily. 6. Peace of mind when away. Gives you confidence your pet is fed when you're at work or away. Some models even offer remote control and camera for monitoring. Thank you for listening.
So this is our final result. As you can see, when the time comes, we set at this time, it would change the screen to ready to feed or feeding now, whatever. So this thing works. And then when it showed this, the food would come down. It opened for 4 seconds and then close, and then it will open next time when we set the time. But we have a little problem in this because we don't put enough food in it. So as you can see from the video that the food comes down very little, but you can hear from the video that it's open and then closed. But sorry for this problem that the food comes down very little. Yes, and then we will improve for the next project, and I hope this is useful for audience and hope you guys enjoy it. Thank you.